um, for being so late. I got stuck at home, and then as I was walking in, of course, my chair pulled me aside for a question. So I'm sorry about that. But we are up and running now. Okay, so again, so let's. Sorry for the delays, but hopefully we'll make it worth it. So let's see. Let me just tweet out too to make sure that everyone knows that we are live. Ours live now. Okay. Okay, good. Okay. So, hello everyone. Welcome to week 7 of an introduction to agent-based modeling. And in week 7, we are going to be covering unit 5 of the course, which is comparable to chapter 5 in the textbook. Highly recommend kind of going through it. And what's nice about unit 5 is that unit 5 discusses how to take apart a model, like what the components of a model are, right? So up until this point, we've kind of been concentrating on building a model, building a model, building a model. Now we're going to take a step back and we're going to decompose that model and think about what the elements of that model actually are, right? And so that's what Unit 5 is really concentrating on. And this gives us a chance to kind of go over some questions that you may not have thought about clearly, but you've dealt with at times. For instance, things like how do you sequence agents' activities, right? Do you do it sequentially? Do you do it concurrently? How do you sequence their updates, right? Do you do it asynchronously? Do you do synchronously? And the Unit 5 really kind of delves into a lot of those concepts in detail. Okay. So that's Unit 5. Also, at the same time, the other big announcement for this week, right, is that the assignment was due on Sunday. Hopefully everyone got it in. Good. And over the next 2 weeks, you're going to be doing your peer reviews. So you have to do 3 peer reviews of fellow assignment, some of your fellow students' assignments, right? And then turn those in by the end of 2 weeks, right? So this is we have this assignment, and then we have the final assignment. You know, there's been a bunch of questions about delays and extensions, and unfortunately, because we have all these students working simultaneously, and because of the fact that we have the peer review has to be done at a certain time, right? Unfortunately, we can't really give extensions, right? If you have a real hard problem, give us an email. We'll see what we can do, but we can't really give extensions. So we'll have to find another way to work around it if you have a problem with that. Okay. Let's see. That's about it in terms of the overall kind of announcements I wanted to make. I'm going to start going through some questions, but I see I already have a question from Chris Butler. But if you have any other questions, feel free to either post them on the YouTube chat. It's a little too late to email them to me because I can't check email and YouTube and Twitter all at the same time. But if you tweet at me, I will try and catch that as well, right? Let's see, pulling up my Twitter feed for this class. Yeah, okay. Yeah, it looks like it's pretty empty right now. Okay. Yeah, one question about submitting the project questionnaire. Oh, sorry, I missed that one. Okay, that was a while ago. So hopefully you've submitted everything and it's all gone well. Let's see. So let's go to the questions. So Chris Butler has a question about using the world and NetLogo. Are there benefits or issues having agents wandering around the world and running into each other as an analogy for randomly encountering things online? So in general, my guidance would be to make the world of your model as close to the world of the thing you're trying to model as much as possible, right? So if the idea is that people are moving around online, right, like surfing, for instance, clicking on different links, seeing what's going on, right, then it makes sense to actually try and build like a miniature web. You can do that, just with nodes and links, kind of like, right? So I would not have them just physically moving around and bumping into each other, right? Now, That being said, right, a lot of modeling is about making an analogy, right? We're not going to model everything. We're not going to model like a click on a particular website probably, right? Because that would just be too detailed, right? Exactly which coordinates they clicked on, right? So if you can create something of them physically moving around the space that approximates the process of clicking on the web in some useful way, right? Then that's perfectly okay, right? But a lot of times the problem is that like the farther you get away from the actual underlying phenomenon that you're trying to model, the more work it's going to be for you to justify the design choices you made, right? So for instance, let's say I'm going to model people randomly wandering around, the turtles randomly wandering around as a model of the web, right? Well, then I have to try and, if I really want to make a good model, I have to justify, well, like, how do people turn? How do they look at different links, right? How do they move, right? How fast do they move? What's the density of the websites compared to the density of the people, right? And so that can be hard to do, right, to make all those. And this is what we call, and we'll get into this in Unit 7 when we talk about validation, but this would be an example of input validation, empirical input validation, or might also be considered an example of micro-face validation, right? On face, do the micro elements of the model correspond to real-world elements, right? So you can do it. I'm not discouraging it, right? Like well, I'm not saying you can't do it. I am kind of discouraging it a little bit. But what I mean is that it's probably going to be a harder road to travel if you want to make a model that actually has a valid reference to the real world. Now, on the other hand, there's a lot of great models that are pure analogies, right? Like the Schelling model, for instance. The Schelling model has this checkerboard, and it has, you know, people just moving in squares. That has nothing to do with like the real world in terms of housing decisions, right? So if the analogy works well, right, which in the Schelling model it does, because even though people don't actually live on a checkerboard and live in they tend to live in a space and they have a few number of neighbors, fairly similar, right? So to that extent, to which the analogy works well, you'll be doing okay. So I hope that helps, Chris. Helps you think it through. I don't think it's, you know, I don't think it's a horrible idea. I think, you know, it's definitely something worth exploring, but I definitely would consider it as you're going along, right? Okay, so Dion Wing-On has a question, sorry. How can we import the social network structure such as Twitter actors following into NetLogo? Okay, so yes, there is some standard import code in NetLogo. And we're going to get into this in more detail in Unit 8 for sure, and probably part of Unit 5 as well too, if I remember correctly. But let me pull up NetLogo and I can show you real quick. So basically there's two standard ways to represent a network in general by network science. One is an adjacency list, which basically says where you just list every single node and you say this node is adjacent to this node, right? And this node is adjacent to this node, right? And the other one is, it's called an edge list, not an adjacency list. I was confusing the two. That's an edge list where you have where you basically each row is an edge, right? A is connected to B is connected to C, B is also connected to D, A is also connected to D, so forth, all the way down, right? So NetLogo can import an edge list. You can do some processing to do that yourself, or you can use one of the network extensions. The other way is often called an adjacency matrix, which is what the term I first used, where basically every row is a node and every column is a node, and you have a value that indicates the strength of the relationship between each of those nodes. Right? So in NetLogo, let me bring this up. Okay, in NetLogo. Okay, there we go. Right. Of course, it's not going to show the models library list, but I can show it to you after I bring it in. Let's see. Oh, why did I have to click? Okay. So there is an example called network import. It's under code examples, right? So this is one that doesn't use the extension at all, right? But if you look at the code, essentially what it does is it runs this import attributes command. If we go oh, sorry, import network. Yeah, import links, right? So this opens a file called links.txt, and links.txt is a file which just has 3 columns separated by spaces. In this example, the links are directed, but you could also do without it. The first column contains the node ID of the node original link. The second column, the node ID of the end link, and the third column is the string of the list. So this is an edge list type of format of storing it, right? So that gives you one way to do it, fairly easy. So if you hit import network, you get this particular network, and I can actually pull up the file so you can see it, hopefully, fairly quickly. Oh, here we go. Okay. So let me add that window in, and you'll be able to see it. Let's add text there. There we go. Okay, so there you go. So there you can see, let me bring it up a little bigger. There you can see the file, right? So node 1 is connected to node 4 at a weight of 0.8, node 2 is connected to 3 at a node of 1.0. And so what does it do? Let's go back to, so let's turn off that one for a second. Right, so in the code, right, it opens the file. It says while not file at end, which is a cool little command that just keeps looping until you reach the end of the file. Let items be read from string, word, file, read line. It puts these brackets on. What this is doing essentially is changing the text that's in the file into a list, a 3-item list, right? And so then it's saying ask get node item 0 of items, and get node is actually a command that's written in this code, which basically says report a turtle that has a node ID equal to that ID, right? And if there are none, it's going to report none, right? So it's going to ask get node, and in some cases, does have to. So the first thing it does is actually read a file called attributes.txt, which tells it how big the network is. So let me pull up attributes.txt. Actually, I can do it easier if I pull it up from here. Okay, file open. Okay. Okay, so let's see. No, it's still not going to work. Okay, I'm going to bring it up. So this is the attributes file. So what you can see in the attributes.txt file, which I should have looked at first, I apologize, it actually creates all the nodes. So it's going to read in all the attributes, and it's going to create a turtle for each attribute, right? And these are the attributes of the node. Now here they're the size of the node and the color, but you can think of them as like wealth or status or job position or whatever, right? And so it's going to set the node ID to whatever the first value is, set the size to whatever the second value is, and set the color to whatever the third value is, right? So when you go and import links, all of the nodes already exist. We know that because we read in the attributes.txt, right, which defined all the nodes. So we don't have to worry about defining the nodes again, right? So here we're just going to get them, and then we're going to create a link from the first item to the second item, and we're going to set the label to whatever the third item was. So that's one example. It's an easy example. It's built in, so I want to make sure I showed that one. But I want to show you one other quick example. Network. So you can use the NW extension in NetLogo, which we've talked a little bit about before. There we go. Okay. Right. Okay. So if you look in the NetLogo network extension, there's actually load matrix, load GraphML, and just load, right? And load imports a given file into NetLogo. It will do its best to match node and edge attributes in the file with turtle link variables.
If the breed is specified for nodes and edges in the file, it will be used. Otherwise, the default turtle and link breeds are used, right? There's some file type specific variants. If you have a file of GDF or GXF or GML, it will load those appropriately, right? And it takes some arguments, the file name, the default turtle breed, the default link bleed, and some additional commands. Anyways, multigraphs, by the way, are not supported in NetLogo in importing. They are supported. They're just not supported in importing. So it's just going to assume every graph is one file. By the way, you can't do GraphML. So load will try and load whatever the file type is, but GraphML will if it is a GraphML file, right? And so GraphML is a standard file type that's used in a bunch of other network analysis packages, right? So things like Gephi and UCINet and some of those, most of them can create a GraphML package, right? And Save GraphML actually talks about what a GraphML package looks like. So that's kind of useful. And then here, if you just want to do a matrix, right, here's just a matrix, right? So this is an adjacency matrix that you can load. These are all different ways to load data. Hope that's interesting and useful for you. Okay. Let's see. Got some other questions that came up. Dian Nguyen also asked what the maximum number of agents. Sorry, I didn't mean to show it that way. That was weird what I was doing there. Okay. So Dian Nguyen also asked what the maximum number of agents is, right? You know, that really depends upon how you your computer and how it's set up, to tell you the truth. Also depends upon how computationally complex those agents are, right? I've done simulations at the level of about 100,000 agents that are very simple without too many problems. It also depends if you're doing a graphical representation. If you don't need the graphics, you can actually run NetLogo headless, in which case you can even expand beyond that, right? So hopefully that helps you kind of try and think about how to do it. But yeah. So Lin Chu has a question. I'm interested in reproducing some differential equation evolutionary models with ABM. Want to see what happens after I relax assumptions about homogeneity, adaptiveness of organisms and environments. Is there anything I should look out for if this type asks? I don't know how others in the literature have done this yet. So first of all, right off the bat, one small issue is that ABM is a discrete language, right? So it's hard to reproduce differential equation models exactly. However, if you have a difference equation version of the model, right, that's much easier. And a lot of difference equation versions can actually be written directly in a nature-based model, right? Because they're of the form x of t plus 1 equals x of t times something, right? And so all you're doing is you're taking that difference equation and rewriting it into the agent level. In fact, in the BAS model, that's essentially what we did. We took a difference equation version of the BAS model and we rewrote it as an agent-based model. So that's something you might want to check out first, right? Trying to figure out if there's a difference equation as opposed to a differential equation version of the model. That being said, even if it is a differential equation, you can think about how to discretize it, right? Which is useful and interesting and important to do, right? So you can think about ways to kind of simplify the assumptions. One example, so I don't know of any that are specific to evolutionary models per se, but you know, the classic wolf-sheep model is based upon a differential equation model known as the local Volterra model, right? And there, you know, they kind of took the rules and they kind of agentified them, if you will. And there's a great example of it in the NetLogo source code. So let me turn on the right window in the NetLogo models header. So let's go here. So NetLogo, as we'll learn in a later chapter, actually does support differential equation modeling via something called, or difference equation modeling, I should say, via something called the systems dynamics model, right? And there's an example of the local Volterra model that is done both in system dynamics and in, is this the one I want? Yes, I think it is. So, so let me add in one more window capture. Let me delete a couple of these other ones while I'm it. Okay. Let me show you what the system dynamics model looks like. Not that one. So here is the NetLogo Systems Dynamics Modeler. If any of you have ever played around with Stella, it's kind of similar to that. And in the standard system dynamics model, right, you have stocks and flows. And if you look at the code, right, it'll tell you, for instance, that the sheep stock is just the initial number of sheep, right, and that the flow out of the sheep stock is equal to, which is the sheep deaths in this case, is the sheep stock times the predation rate times the wolf stock, right? So this is kind of written in your standard difference equation format, right? And then it will just, and all the T's are kind of elided because we don't need it because we know it's happening on a tick level basis, right? So in this model, which is kind of intriguing, we actually have built both an agent model. Oh, it's, can you see that? You can't see that whole thing. Hold on, let me make it a little bit smaller. Is that better? No, it's still not any better. Let me make it a little small. There we go. Okay, so you still can't see the whole thing, but I can kind of scroll for you now. Okay. So in this model, on the left-hand side, you have. You know, maybe I can make this window bigger. Hold on. Sorry about this. Let me see if I can help you out. No, that's the wrong one. I'm going to do this one. There we go. Stop grabbing the wrong one. There we go. Okay. Makes it a little bit bigger at least. Okay. So, yeah, it's not really helping, but it helps a little bit. Okay. So, in this case, on the left-hand side, you have the agent model. And so this is the agent version of the model, and you can run the agent version of the model. And you can see the populations. And on the right-hand side, you actually have this, what we call the aggregate model, which is actually a difference equation model, right? And so if you run this, you'll notice that the world doesn't change, but you see the graphical results, the differential equation results of the model, right, going on. And so the interesting thing here is you can actually set up a comparison where they're both set to the exact same parameters, and then you can run the models side by side, right? So you have the agent-based model results and the difference equation. And as you can imagine, right, because the difference equation results are real valued, not discrete, right, it's easier to kind of have them all set up and be manipulated, right? So you can see the differences that exist there. Len, that would be a good place to look, a good place to start, so you could kind of look to see a great example. So Kay Behrens asked, why is NetLogo implemented a mixture of Java and Scala for concurrency support? When I was actually working on the development system a while ago, it was actually all in Java, and they started to move to Scala as part of the implementation as I left. I think it's more for ease of coding, for ease of managing the actual language library than it is for concurrency support. But really, that's a good question to ask Seth Tissue, who's the lead developer on NetLogo. I'm not quite that much into those design decisions at this point, but that was my impression when chatting with him about it a couple years ago. One place that Seth is always hanging out is on Stack Overflow. So if you go on Stack Overflow, tag a question with NetLogo and ask him there, I'm sure Seth will give you an answer. Sorry, I can't be of more support. I don't know why that particular design decision was there. It happened kind of as I was leaving the development team. Anyways. Okay. And if there are any other questions, feel free to shoot them along. I'm going to check the Twitter feed real quick. It looks like there's nothing new that's coming there, nothing new on the YouTube channel. I did have a couple of questions. They're over here. My other notes. Sorry. Oh, I should stop making that thing pop up and down at me. Okay, there we go. That's better. I got a couple of questions I wanted to kind of comment on over the last week. One was, what sort of maths do we need for NetLogo for agent-based modeling? And do we need to have a math equation at all? Right? After all. And, a lot of people think of It's a hard question for me to answer because from an agent-based modeling perspective, I want to say I take this position a lot of times where I just say there is no math, it's computer code, right? But that's really me being kind of facetious and kind of just fighting fire with fire because everyone always wants to have a math equation. Not everything has to have a math equation. A lot of times computer code is easier to understand than math. That being said, right, I mean, not for everyone, but for many people it is. That being said, right, a lot of times the actual updates and the changes of properties that we have for our agents are driven by a mathematical equation of some sort, right? And really it depends upon, what particular types of things you're trying to embed, what kind of math you need, right? So, as we just talked about, you might be taking a differential equation model and building a discrete agent model out of it, right? And that's very different kind of a mathematical approach than if you're kind of starting with, say, a game theory model and then building a model from that, right? And so it really depends on what you're doing. That's kind of the question I'm getting to. And you might hear me say at times there is no math, it's just computer code. That's more of me just kind of wanting to deny the first principle of math, that people think of math as the greatest language. And it's just another artificial language, just like computer code is an artificial language. And so therefore, it's another way of expressing ideas. That might be considered heresy in some places, but I often try and argue that it's just about the representation. Whatever representation is most useful for gaining knowledge is the representation that you should be using. Okay, and that representation should vary from person to person, right? Someone with 5 years of differential equations under their belt, right, or say 20 years of differential equation work under their belt, is going to see certain things as easier to understand than someone who has spent 1 year learning NetLogo, right? So it really depends. There was some question about breed interactions, right, which I thought was kind of interesting. And there are a couple of ways to check breed interactions, right? So I wrote a small little piece of code and thought I'd demo it for you real quick. So let me bring back up the NetLogo window. Okay, let me clear this whole thing though. File new. Okay, so I wrote a kind of, so we learned a little bit about breeds at the end of the unit 4, but we didn't really talk too much about how to check breeds, right? Except for there was a little bit about that, right, where we're asking just the wolf or just the sheep to do something. But what if we want to have one breed interact with another breed, right? So I have this code, right? Create enemies, 10. Ask friends, create link with one of the enemies, right? Ask enemies, create link with one of friends, right? And I'm just going to do some little set x, y, random x core, random y core, just to spread them out in the world, right? So what I'm doing here is I just created 2 groups of turtles, right? One is friends and one are enemies. Let's spell friend. Fix that real quick. And I created links between all of them, right? Oh, I actually put that link in there. That dash in there. Right? So now I have a little network. If I hit setup, right? I get a little network of turtles there. Let's actually do one like set color green for friends, set color red for enemies, just to make it differentiate. Okay, so there we go. Now, what if we want these in? Let's actually make this a little more complex. We'll actually have the create link with one of other friends. Right, so each friend will be connected to one friend and one enemy, and each enemy will be connected to one friend and one enemy, right? And enemies. helps like type correctly or spell correctly. Okay, so here we go. Let's do that setup again. All right, so now each one has 2 links, one to a friend and an enemy. Some of them have more than one because of the fact that they might be connected. Someone else might have connected to them, right? So now, if we're going through or having these turtles all do something, right? We might want to have them behave differently. Well, let's do friends first and then enemies, just so we know who we're talking to, right? We might want to have them do something differently if they're friends or enemies for their linked neighbors. So they're interacting with all of their linked neighbors, who are all the people who are connected to them, right? But if they are a friend, and I'm a friend, all right, then maybe we do something like set size of the friend to size plus 0.5, right? And if they are an enemy, and I am a friend, then I'm going to set their size to size minus 0.5, right? So it's kind of like, with their friends, we make them feel good about themselves, they get bigger. If they're enemies, we make them feel bad about themselves, and they get smaller, right? That's kind of the idea here. We'll copy that code down here, but we're going to change it so that enemies are nice to enemies and mean to friends, right? And by the way, if breed equals always assumes the plural. So I need to change that. I screwed that up here too. Huh? So it assumes that you're looking for the plural. Right? So now if we hit setup and now we hit go, right, you'll see some of them get bigger and some get smaller over time depending upon how many friends or enemies they're connected to. But the point of this code, the reason why I typed all this is that someone was asking on the forum, if I have a link and I need to interact differently if someone's a friend versus enemy, how do I do that? Well, this is one way, right? I can ask all of your linked neighbors to interact with you, and then I can check and have them do something differently if they're a friend or an enemy, right? So this is one way to do it. The other way, you can also write a command that takes a path. So one way we could have done this differently was we could have just asked all turtles to do this code, right? And then we could say if is friend, if it's the right family, double check that. I think it's if is friends actually, and then if is enemy. So this checks yourself. Okay, let's see if I did that right. So if is friend, and then you have to give it something, so you can say self, right? Which is kind of a weird way to say it. You could have also done if breed equals friend, and that would have done the same thing, right? So this just gives you another example of how to check what the breed is. Enemy. So for some reason, is takes the singular, but breed equals takes the plural, right? So I'm going to set up, go, and it does the same thing. Okay. Yeah. So just a couple of ways to kind of check to see what the breed of a particular object is. Hopefully that's helpful in some way. Okay. Let's see. So we're running out of time a little bit. I did start a little late, so I'll go a little bit late. I think I just have 2 more questions I want to talk to. So someone asked about importing GIS data, much like importing networks data. That's something we're going to be covering in the upcoming units. Chapter 8 definitely goes into it in detail. However, if you're interested in it right now, I recommend looking into the GIS extension on NetLogo, and that would be a good way to do that, right? Oh, actually, they were asking about how to import like real population data into a model, right? And you can basically go to in the US, you can go to the Census Bureau, and they have all the data sets for all the census available. You can download that data set, and then you can import it. And I will have an example of that in Chapter 8, or Unit 8. So there will be an example exactly of how to do that. It's also in the textbook if you want to skip ahead and look in there. I think maybe actually, let me see. There might be in the models library under Um, IBM textbook. Let me check real quick. Yeah, okay. So let me show you real quick. There is an example in the models library. It's called ticket sales. It's under Unit 8. And it takes a little bit longer because it's actually reading in a bunch of data from some very detailed GIS files to set up and run. But once it gets up and running, it shouldn't take that long, you will see a map of New York City, Manhattan, in which every agent is equal to about 10,000 agents, and they are distributed according to the Census Bureau's population density. And you can do things like toggle off and on the road display and so forth. And each of these little agents, which you can't see very well, is equal to 10,000 people, if I remember correctly from the model. And then what happens in the model is an event comes to town, like the circus, and then it chooses the location, and based upon its location, people decide whether or not they're going to go based upon whether or not their friends are going to go, right? And it's kind of interesting because you can see nice patterns of behavior. You can also notice that things like Central Park actually prevent people from crossing over a lot. They serve as a barrier, which is not a bad thing necessarily, right? So if an event happens up here, up towards the Central Park, it's less likely that people of West Central Park will come to it and so forth, right? Which is kind of fairly realistic, right? So we can actually reset the event and let it go again, reset the event, let it go again. There's one up north, right? And you can kind of see where people draw from. So in this case, right, this one is closer to the western side of Central Park, and so fewer people from East Central Park Eastern Central Park than West Central Park. So that's the model. The code is actually fairly compact, right? Basically, you just have this GIS extension you have to call, and then in load patch data, right, it's going to load this households.txt file, which has the population of each census tract, and then it's going to assign that population and create turtles around there with that population. And where's the setup maps? So the other thing it has to do is actually read in the maps file, and they're stored in what are called GIS shape files, which is a unique form. It's good. There's a standard GIS code that will load that in, and will basically, once you have it set up, will display it. It displays it, by the way, not on. You can either have it displayed. You can either have the information somehow imported to the patches if you want, which is what is done with the actual tracks data set. So that what that does is assign to each patch the census tract that represents it, right? But in this case, all we're doing for the roads, for instance, if you look at the roads, all we're doing there is just putting them on the drawing layer of Netlog. And the drawing layer of Netlog is something you can't interact with, right? It's where the turtles draw, for instance, right? So it's just a visual representation. It has no content in the model itself. Okay. Let's see. So, so K-Brands has one question. So for a superpower user, does headless mode become the default mode, e.g. for optimizing grid search or sensitivity analysis? I don't know if it's even a superpower user. It might just be a power user. I don't know if I would call it the default mode, right? You often do all of your model development, model exploration in the graphical mode. And then headless mode is where you actually generate the results that you're going to use for your actual analysis and for your experiments and everything like that, right? But, it's kind of a weird thing to say, right? Do I run NetLogo more in headless mode? Probably based upon CPU time, but not based upon my experiential time, right? So my experience is much more interacting with NetLogo in the graphical mode. But yeah, I probably churn up a lot of clock cycles with it in headless mode. So I don't know if you call that default mode, but it's definitely where the vast majority of my compute cycles are spent. So maybe that helps to answer your question. So there, I've got a bunch of questions. I forgot to mention this with the assignment of people asking about what happened? When do I have to do the assignments? When are things done? And I've tried to make it very clear that the calendar is up, that has the deadlines on it and everything like that. There's only 2 assignments that have any deadlines related to them. And that is the model design assignment and its peer review accompaniment, and the final project assignment and its peer review accompaniment. Everything else you can do whatever you want as long as it's done by August 31st, and you get it all done by then, right? So hopefully that won't be a problem. So that means you can go on a week's vacation as long as you're caught up to speed on all your peer reviews, and as long as you're still going to get through and do all the exams by the end of the course, you're fine, right? Moreover, all that stuff, all the exams and all the peer review assignments, getting them in on time at all, you're just doing that to get the certificate. If you don't care as much about the certificate, you just want to go through the course, right? You can do any of the assignments whenever you want, right? And the content will be up basically in perpetuity until we launch the next version of the course, right? So you can keep working with it, keep looking at it, the videos and everything like that, right? So those will be up there for a while now, okay? Okay, one last question. I should have addressed this a little bit before, right? Someone asked how you can, if you have 3 different breeds and you want them to interact in different ways, how do you do that? Well, this is, and have different types of interactions. So we haven't talked about this yet in the course, I don't think. But besides breeds, there are also linked breeds. So let's say I want to have consumers and retailers. And I want to have consumers linked to each other. Oh, I have to say undirected or directed. Screw that up. Sorry, in the discussion form, I think I forgot to say this. Undirected linking. So I can have purchase, right? And I can have word of mouth, word of mouth, right? It just means, an influence from one consumer to another, right? And so if I do this, create 100, create consumers 100, wow, sorry, it took a while to get out, create retailers 100, set XY, random X4, random Y4, set shape person, set color blue, just grab that setup code again. Except I'm going to set their shape to house and set their code color to red. Right, okay. Now, let's say I want to just create 2 different networks, right? So I can ask consumers create word of mouth with one of other consumers. And I can give that link some directions just to make it show. So I can set its size to 0.5, set its color to green, right? And then I can also have the consumers create purchase with one of retailers, set size 0.2, we'll make it a little smaller, C3, set color, try to figure out that yellow, okay. Set, it's not set size, it's set width. Set thickness, set thickness. And so once we've done all this, right, oh, that's a little busy. Maybe we should do 10 just to start out. And don't forget my clear off. So here you go, right? I've got these 10 consumers. They have these green lines linking them to other consumers, indicating word of mouth influence. And I also have yellow lines linking to the retailers, increasing purchases, right? So the nice thing about link breeds is it allows me to have two different types of links in the same network indicating different things, right? And then we can have those have different effects, right? So I wasn't quite sure what the original questioner was looking for, RF Maeda, but I think that this kind of at least gives them some understanding of how to add in these different structures. Okay, let's see. Any last questions? So I think that's all from the forums I want to cover. K-Brands, by the way, came back and said, okay, I understand it's maybe 60% graphic, 40% headless or so. Yeah, I mean, like I said, it's mainly like I'm not dealing with NetLogo when I'm using it headless, right? I just write up the code to let it run, and it goes off and runs. It's hard to quantify easily. Okay. So no other questions on the YouTube channel, and it looks like there are no other questions on Twitter. So I think I'm going to call it a day. We'll be back next Tuesday at 11 o'clock, and this time I will make sure to be on time since I was late this time. I apologize again for that. I hope that everything's going well. Just as a reminder, this week is Unit 5. Please, please, please make sure and also go through the peer review feedbacks. Okay, take care, everybody.